This lesson is on factoring a quadratic that has a lead coefficient of 1. So your lead coefficient is just the number that is in front of your x squared term. That's all that means. So this method is pretty straightforward when you have a leading coefficient of 1. So we want to write this in factored form, which means we want a product of factors. So step 1, identify the factors of your C term. So identify factors of your C term. So what are the factors of 6? Well, 1 times 6 and 2 times 3. Step 2, what are 2 factors of your C term that when added give you your B term? So when I add these 2 numbers, which one will give me my B term, which is 5. So we can see that 2 plus 3 is 5, 2 times 3 is 6. So we need a sum of 5. And then step 3, write as a product of factors. Okay, so that's going to give me x plus 2 times x plus 3. That's expressing this quadratic that's in standard form in factored form. Now, there are some benefits to having it in factored form. We can quickly identify the x-intercepts. So what value of x here would make this entire factor equal to 0? Well, x plus 2 equals 0. Well, that is true when x is equal to negative 2. So one of my x-intercepts is negative 2. The other x-intercept is negative 3. And it's common to write these as ordered pairs. So that would be negative 2, 0, and that would be negative 3, 0. So let's look at why that is. So here we have our x squared plus 5x plus 6 graphed. So you can see your x-intercepts are indeed negative 2 and negative 3. And your values of y are 0. They're 0 because when your graph crosses the x-axis, your y value is always going to be 0. Alright, so let's go ahead and practice a few of these. So let's say we have x squared plus 9x plus 14. So again, step 1, identify the factors of your C term. So in this case, 2 times 7 and 14 times 1. Well, which of these factors, when added, give you your B term, which is 9? And 7 plus 2 gives us 9. So we know our factors are x plus 2 times x plus 7. Now, if the question just asks you to express this quadratic in factored form, you're done. But if you needed to evaluate this factor, or this quadratic, and identify its x-intercepts, you need to take it that one step further. What value of x could I plug in here to make this equivalent to 0? X plus 2 equals 0, subtract 2, when x equals negative 2, and when x equals negative 7. But again, go ahead and write these as ordered pairs. So this means this quadratic, its graph will cross the x-axis at negative 2 and negative 7. All right, let's try one more with some negatives thrown in there. So same game, what 2 numbers when multiplied, or what are the factors of negative 16? So this time I need a negative 16. So the factors of 16 are, we could have a negative 4 and a positive 4. We could have a negative 2 and a positive 8, or a positive 2 and a negative 8. Or a 16 and a 1. Could be negative 16, could be negative 1. So out of all of these factors, which ones have a sum of negative 6? Well, negative 4 plus 4, 0, so that's out. Negative 2 plus 8 is equal to a positive 6, so that's out. 2 plus a negative 8 is equal to negative 6, so there we go. We're going to go ahead and write this as a product of factors. x plus 2 times x minus 8. And we can always double check our work by distributing and getting this factored form back into standard form. So remember, with quadratics, you use, I don't like the term FOIL, but a lot of people are familiar with it, so first, outer, inner, last. I just think of it as multiplying this x by everything on this equation, or on this side, and multiplying this 2 by everything, and adding like terms. So x times x is x squared, x times negative 8 is negative 8x, 2 times x is positive 2x, and 2 times negative 8 is negative 16. And then when I add like terms, I get x squared minus 6x minus 16. So yes, I know I factored it correctly. Now, if the question asked me to identify the x-intercepts, I would set each of these equal to 0 and solve for x. So x-intercepts would be negative 2 and 8.